Hello and welcome to GP Podcast. Today we're diving into something truly fascinating. It's a technique for teaching artificial intelligence that's so powerful it helps an AI learn not just to answer questions, but to actually reason its way through problems it has never even seen before.
You know, it's one of those persistent puzzles in AI. We have these language models that are just incredible. They can write poetry, they can write code, but then they can totally stumble when a familiar problem is just presented in a slightly more complex way. This is the exact gap we're exploring today. The huge difference between just knowing something and truly understanding.
So there's actually a technical term for this problem. It's called easy-to-hard generalization. And put simply, it means that most machine learning models, well, they're trained on a specific set of examples, and they get really, really good at solving problems at that exact difficulty level. But the moment you ask them to tackle something even a little bit harder, they often fail. And I mean, they fail spectacularly. And this comparison here just frames the core challenge perfectly, doesn't it? We humans, we can learn a concept from just a couple of examples and then apply that same logic to much harder problems. Machines, on the other hand, have always struggled with that leap. They are absolute masters of pattern matching within their training data, but that genuine, flexible reasoning, that's the gap this new technique is aiming to close.
Okay, so to try and solve this reasoning gap, researchers first developed this really powerful method called chain of thought prompting. And believe me, it was a massive step forward in getting an AI to actually show its work.
The idea behind it was just brilliant. Instead of asking an AI for only the final answer, you'd ask it to think out loud, to show its reasoning step by step. You know, just like your math teacher used to make you do. And this process, laying out the steps, it dramatically improved accuracy on complex tasks and made the AI's reasoning way more transparent.
For all its power, chain of thought prompting had this hidden flaw, a kind of Achilles heel that would only really show up when the problems got really hard.
This quote from the researchers really highlights the crucial point. So if you show a model a bunch of examples of how to solve a three-step problem, it gets amazing at three-step problems. But what happens when you give it a five-step problem? Well, that single continuous chain of thought can break really easily. One small error right at the beginning can just derail the entire process.
So how do you fix a broken chain? Well, the solution is this elegantly simple idea, and it's borrowed directly from the way we teach children. It's called least to most prompting.
So instead of trying to solve the whole thing at once, this method first teaches the model to be a good project manager. First, it breaks the big, complex problem down into a series of smaller, more manageable questions. Then, and only then, does it start solving them, one by one.
And this diagram just illustrates the process perfectly. Take a look at stage 1. The AI gets this main question about Amy in the slide. And the first thing it does is figure out the necessary subproblem, how long does each trip take? Then, in stage 2, it solves that first, gets the answer, 5 minutes, and then it uses that answer to solve the original final question. It's not one long chain, it's a series of strong, interconnected links.
And what's so cool about this is it's not just some programming trick. It's a fundamental teaching strategy. It is exactly how a good teacher helps a student tackle a complex new skill. You don't start with the final performance, you start with the basics and you build up, from the least difficult part to the most difficult. We're just applying the logic of education to artificial intelligence.
So does this whole educational approach actually work for an AI? Well, the researchers put it to the test, and the evidence they found is nothing short of a breakthrough. Now, to really appreciate these results, you have to remember the difference in approach. Chain of thought is like a single sprint. It's fast, sure, but if you trip, the race is over. Least to most is a relay race. Each step is its own segment, securely passing the baton to the next one.
The researchers used a test called the SCAN benchmark. Now, this thing is specifically designed to test something called compositional generalization, which is basically an AI's ability to combine simple commands it knows, like walk and jump, into new, much longer sequences it's never seen before. It is a notoriously difficult test of reasoning.
And here are the results. With chain of thought prompting, the model scored a mere 16% accuracy. It almost completely failed. But with least to most prompting, it achieved 99.7% accuracy. Let that sink in for a second. That's not just an improvement, it's a total game changer. It went from failing the test to completely acing it, solving the very same mystery of easy to hard generalization that we started with.
You can probably tell this is bigger than just solving word problems or command sequences. This points to an entirely new direction for AI development.
So, what's the big picture here? Well,
This matters because it creates a more robust and reliable AI without all that expensive retraining. Think of it like this. The knowledge was already inside the model. This technique is like giving it a better instruction manual for how to use that knowledge to solve new, harder problems. It's about teaching the AI how to think more effectively.
And that really is the fundamental takeaway. The true innovation here isn't just about getting a smarter answer. It's teaching the AI to value the process, to understand that the path to the solution is just as important as the destination itself.
And this leaves us with a fascinating, kind of mind-bending question for the future. I mean, if we can teach machines to break down problems and reason in this structured way, we're not just building better tools, we might be creating partners in problem-solving that can help us tackle challenges in ways we haven't even conceived of yet. If you like the video, subscribe, leave a like, comment on what you liked most, and share the video.